Hey everyone, welcome back. Today we will be looking at LeetCode 35 search insert position problem. We are given an array of distinct integer and we need to find the target value's position in the array. In this example, the target value is 5 and we want to determine if it exists in the input array. If we find the target, we return its index. In this case, the index is 2. However, there will be cases where we don't find the value, and in those instances, we return the index where we would insert the value to maintain the sorted order of the array. Since the input array is sorted, our initial thought might be to search the array from left to right, comparing each element with the target value. However, there is a more efficient solution. Can we improve our linear time complexity from O of n? Yes, we can. The hint is given that input array is sorted, which we can use to our advantage. To achieve a more efficient solution, we can utilize binary search, which has a time complexity of O log n. By applying binary search, we can find the target or determine the index for insertion in a much faster manner. So the question is, how are we going to implement it? There is a standard algorithm called binary search, which is more efficient solution for a specific problem. Instead of checking every value, binary search takes the advantage of the fact that the input is sorted. The algorithm starts by initializing two pointers, a left pointer and a right pointer, and computes the middle value between them. If the middle value is not the target, the pointers are updated based on whether the target is greater or smaller than the middle value. This process continues until the target value is found or the pointer converges, indicating that the target does not exist in the input array. In later cases, the algorithm determines the index at which the target would be inserted by shifting the left pointer and returns that index as the result. Binary search has a time complexity of O of log n, making it more efficient than O of n. So let's implement the code. We initialize our left and right pointer to 0 and the length -1. And now we can start our binary search. While the left pointer is less than the right pointer, we perform the following steps, and we need to make sure that the left pointer hasn't crossed the right pointer. So while left is less than equals to r, we will perform the following steps. To compute the middle pointer, we calculate the sum of left and right and divide it by 2. So for middle pointer, we will do left plus right divided by 2. In Python, we can use double slashes for integer division. The first thing we will check now if the value is at the middle index. So if we check if the value is at middle index or not. If it is, then we can return the middle index. If middle is not equals to the target, there are two possibilities. One is that the target is greater than the nums of middle, and the other case is the target is less than the nums of middle. In which case we will update our left pointer to search our right. So we will search if nums of mid is greater than the target. In this case, we update our left pointer to search towards the right. So we will update our left pointer to search towards right. The other possibility is that the nums of middle is less than target. In this case, we will update our right pointer towards the left. Where smaller number exists. If we never find the target, we return the left pointer. If we never find the target, we will return the left pointer. This choice is made because if the target were to be inserted into the array, the left pointer indicates the current position. It aligns with the index where the target should be inserted. This approach ensures that our code works efficiently with a time complexity of O log n, where n is number of size of input. Now let's implement the code in LeetCode. First of all, we will initialize our left and right pointer to 0 and length of nums -1. Now we can start doing our binary search. While left is less than equals to r, we will initialize mid as left plus right divided by 2, and then we will check if target is equals to nums of mid, then we will return mid. If target is greater than nums of mid, then we will update our left to more left. Or the other possibility is that we will update our right to mid -1. If we don't find any element, then we will simply return low, which will indicate the current position. Let's try to run code. Okay, let's try to submit. Okay, thank you for watching. Let me know if you have any questions.